quick way to launch into whatever language it is you want to learn. So once you just identify the language you want to learn, then W3 Schools will help you go in there quickly, as fast as possible, without any frills. So that's why I actually like it. But so what we're going to do is we're going to continue from where we stopped last week. And just by way of refresher, we're going to be talking about variables. So last week we told we discussed about what a variable is, and I told you that a variable is just a container, just any container that you use to that you just use to hold any value. Basically, the computer is very dull, and because the computer is dull, what it means is that you have to tell the computer everything. So when you want to tell the computer, hey, I want you to mark this this phone. This phone is probably a Huawei phone or something, or a Sony or Samsung phone. So you have to tell the computer. So the computer can make a space in its head or in its memory, if you like, to just know, okay, so when I mention this variable, this is what is meant. All right. So that's what we talked about last week. So for as a way of example, you might want to say, okay, computer, as of today, how many people are in class? So say number of people in class. All right. And then tell the computer is equal to 4. So that way, when you want to refer to it much later, and you want to ask the computer, how many people were in class? All you need to do is just to ask the computer, tell me the number of people that were in class, and the computer will tell you 4. So that's basically what a variable does. A variable is you telling the computer what you expect, and you telling the computer, hey, just put this in your memory for me. Later, I'm going to ask you about this thing, or just identify this thing as this. All right. So that's basically what a variable is. And like I told you, why we use this because the computer is very dull. So we have to keep telling the computer, this is a book. The name of this book is Alice in Wonderland. So we have to create a variable inside the computer set for Alice in Wonderland, so that when we try to tell the computer, hey, computer, I need that storybook. What's the name of that storybook again? It just tells you Alice in Wonderland. So that's what you do with variables. All right. Now, sometimes you can change the value of variables. That's what we call variable notation. And though it's same thing, or you have changed the value. So for example, we had initially told the computer that the number of people in class is 4. And now maybe somebody joins, and then we tell the computer, oh, somebody has joined, its number of people is now 5. So when we now ask the computer, tell us the number of people in class now, guess what the computer is going to output? 5. So same variable name, but because there has been a change in value, something has happened, and the computer has now, oh, okay, so it's now 5. It's now an update. All right. So we can even decide to go like this, say 4 plus 1. And the computer will still churn out 5. So it just tells you that, hey, when you want to change a variable, you don't need to start doing any special gymnastics. All you just need to do is just change the value of the variable. Just assign something new to it, and you're good, and the variable changes. Some other times you might want to change the type of this variable. So for example, the number of people in class right now is 5. And last week when we talked about variable types, we said that this 5 belongs to a variable type called integers. All right. So I could confirm that by just asking the computer to give me the type of this number of people in class. And rightly, you're going to see the computer is going to tell me it's an integer, all right? So, but what if we say number of people in class equal to 5, and we put this here, all right? Let me just cut this off from here and put it here, just for ease of remembering. All right, so now if I come here and I now ask the computer, what is the type of the number of people in class? It's going to tell me a string. Do you notice what has happened? We have changed the variable, not just the value, but the type. So the moment you put inverted commas behind and in front of a number, it becomes a string, it becomes a piece of text, all right? Now you cannot run the regular addition and subtraction that you want to run in this, you can run that in this, yeah. So so that's the way it works. That's the way it works. Now, so we are going to the next thing on the list there, which is operators. So how do we use these operators in Python? Okay, so to use these operators in Python, let's start with the plus. Now, many times when you see this plus operator, you're going to feel like, remember, you can stop me at any time. That's why it's a live class. So anytime you see me do something that you don't understand or you have a question, please just come off mute and then just stop me, all right? So whenever you see this plus sign in a programming language, plus does not just mean addition like in math. Let me give you an example. So if I say 5 plus 5, obviously that's a 10, all right? But what if I say other plus post? Now, on a normal day, you would say this is an arithmetical operator. It can't work because other is a word and post is another word. But that's the thing with programming operators. So here we are. It works. So it just adds, it concatenates the two text values. All right. So when you see an operator in a programming language like Python, what it's doing is very simple. It's just concatenating two things. And it's not restricted to numerical. If I put two texts here, it's going to work. If I put two numbers, it's going to work. If I put two, whatever, any two things that I put, is just going to concatenate them together if they are not numbers, all right? So that's the first operator. The second operator that we have there is the equality operator. And this equality operator is also called the assigner, all right? If you like, I could just assigner or assigner, depending on what part of the world you're in, okay? So what we use it to do is to assign values to something. So I can say name A equals to, or let me use name of person A equal to, okay, and then name of, name person B is equal to Ndita. All right, so when we do this and we run this out, what we see is, okay, so let me print this out. So print name person A, and the print. Okay, so basically what this does is it just assigns a particular value to a particular variable. That's it. But if you want to check for equality, then what you use is a double equal sign. So you use this one to assign, you use this one to check for equality. So I want to check if, I want to check, so name person A, is it the same thing as, and that's what the equality means. Is it the same thing as name person B? So when Python weighs it together and checks, it's going to tell me, no, it's not true. They're not the same. Every time you use this equality, you have just two answers, true or false. No other answer, all right? So especially if you're using it in this kind of dimension, all right? But most times you use them to evaluate a Boolean logic, like is 1 equal to 2, is the name of the person A is the same thing as the name of person B, is, you know, all those kind of logic. So that's basically what you do with all of those, all right? So the next operator we're going to look at is the star operator. Now, this star operator is a mathematical operator. Let me just open this up. And so if we do 5 multiplied by 5, we get 25. So that's it. Now, if we do this in a text, let's say other star and boost. Let's see what it gives us. Error. Okay, so this one is, you see, you can't multiply a sequence by a non-integer type, which is a string. So that's why it gives us an error. This one is purely a mathematical operator. All right. So same thing for this one. This one is raised to power 2. So if we do this, let's say 5, and we do this 2, we are looking at 5 raised to power 2, which is 25. So whatever you have here is, oh, sorry, 5 raised to power 5. Sorry, I keep using the shift key. All right, so 3 1 to 5. Now, again, this is a pure mathematical operator. If you put a text here, like the raised to power, okay, I think someone has a question. I'm going to come there shortly. Okay, we can use star to multiply a string, e.g. other times 5. Absolutely, you can. You can do that. You can do that. You can use it to multiply, but that's the thing. It now becomes a multiplication. It becomes a multiplication. Yeah, it becomes multiplicative. That's what I'm trying to look for. Okay, so if you do other times 5, yeah, you get other, absolutely. But that's the only thing it can do, just multiplication. Unlike the plus sign that can give you, unlike a plus sign that can give you an addition and a concatenation. So you have 2 different functions being done by one sign. All right. So this is an and, all right. And what does this do? What does the ampersand do? Anyone? Okay, so yeah. Anyone? Okay. You can comment from it actually, or you can type it in the chat. Okay. Okay, so let's look at what, let me see. Okay, so okay, so let's look at, let's try it out. Now let's have A equal to 5 as a variable, and let's have B equal to 4. So let's look at it this way. So let's say A and B. That's what it gives us. So when we do A and B, then let's use another keyword called and. Sorry, let me just read this. And then, okay, so A and B. Right. Now, why does 5 and 4 give us 4? Anybody? Anyone? Why does 5 and 4 give us 4? Okay, so this is called a bitwise operator, all right? And I'm not going to bug you with what bitwise operators do, or what I'm just going to tell you right now is, okay, you know what? We're going to get to bitwise operators towards the end of the foundations class, because we're going to need them in a bit more detail. So let me not bug you with that right now and get you confused. But basically, that's what the and sign. It's a bitwise operator. This too is another bitwise operator. They are called double pipes. That's what we use for or. All right. So there are bitwise operators that we'll look at possibly maybe next week or next 2 weeks when we start getting things into the real intense level where they get to. Okay, so let's just look at this last one. This last one is modulo, and it just tries to find the remainder. So, but this is also another multifunctional operator. So for example, if I say 3 is 2, what I'm asking Python for is what remains when I divide 3 by 2. So this operator is what you call modulo. Modulo is, if you use Excel a lot, you'll also know this function. It's called a mod function in Excel. So basically what it does is it helps you just find what is remaining in this context. And you'll need this a lot when you start evaluating logic, because that's one of the things you will do in programming languages. When you're using programming languages, some things might not be very straightforward, but then you now have to bring in some logic to try to, get what you want by working around that logic. So those are the times that you need things like this modulo when you're building your solutions in Python. All right. Sorry. So the next thing we'll do in Python, just a little math, but I think you guys are all gurus, so I am not going to dwell on this. Now, when we get to libraries, we are going to talk more about these, because yeah, there are some basic math functions you can perform without having to import any library. But then there's some other math functions that you really need libraries to perform. So for example, if I want to get, like we've done 3 plus 3, it gives you 4, all right? 3 minus, maybe 3 minus 2. Never mind that I leave a lot of space. I can also do this 3 minus 2 without space, and it will answer me, but just to make things a bit readable, I like leaving space, and Python doesn't mind. So it makes things a bit easier. All right. So same thing for multiplication, division. So when you want to divide, you use this. And yeah, when you want to find the square roots, who can guess what you use? Who can guess what you use? Okay, so the square roots of, let's say, the square roots of 4. How do we get it? Remember, 4 is 2 raised to power 2, all right? So what is the square root of 4? How do you get the square roots? Anybody? Anybody? Okay. Let me see the responses. SQRT. Right. Now, if I say, okay, let me use SQRT and let me put 4 on the inside. Now, you see there's a problem. And that's where modules start coming in. Because for me to use this SQRT function, I have to import a module called math, all right? So that module is what handles a lot of all of this mathematical equations and all that. So I can now decide to say math dot square roots, and then I put the number, and I get my 2. So I can do this with math as a module. I can do it with NumPy. I can do it with SciPy or any of all of these modules that are mathematical in nature. Even Pandas has the square and square root function inside of it. So that's how these things work. Now, somebody would want to ask, why didn't Python build in a square root function? Well, there's only a limit to how many functions you need to run your programming language. So every other thing that you need really can go into libraries. And that's why Python is a very library heavy language. From the last time I checked PyPy, there were over 200,000 libraries in Python. There's a library for practically anything you want to do. If you want to cook, if you want to make ice cream, I'm sure there's a library for that. All right. So that's how it works when you want to do the square roots. Now, what if you want to receive a user input? So you want to ask somebody for their name and then use the name in an output. So for example, you want to receive somebody's name, all right? And then print hello username, all right? Sorry, this is supposed to be a plus. Okay, so that it will print out the person's name. Now, how do you get to do that? Especially when you do dynamic programming. So you use this keyword called input, all right? And what the input keyword does is it takes whatever you supply to it. So what is your name? Okay, let me see. Can we use print hello username? Okay, we're gonna try that right away, and we're gonna see how it pans out. All right. Okay. So let's just do it right away. That is using the comma and not the plus. Okay. Yeah. Obviously, we can. Sure. We can. You can use anything. All right. So what I'm just doing here is is just the comma and the plus are just the formatting. The variable will always be there as long it will always be called as long as it's there. So let's just try it out. So when I do this, system brings a prompt saying what's your name. So if I put your name, okay, or let me use Bamidele. All right, and I press enter. It says hello Bamidele. Now your question was, what if we use the comma? Yeah, it should, let's see. Bamidele. Yep, it works. So the punctuation there is just that plus there is just a, a lot of things have changed from Python 2 to Python 3, all right? So I know I used to know a bit of Python right from Python 2, so there's still some Python 2 specific syntax that is going to be a problem just disappearing, all right, from my head. So yeah, it works, right? So, okay, and hello, okay. All right, so that's how you receive user inputs into your code. And now let's talk about Python operations. There are different kinds. If you remember last week, we talked about two kinds of stuff. We talked about data structures, and we talked about data types. Okay, let me use comments instead of data types. And we talked about data structures. For data types, we talked about things like integers, strings, booleans, all right, etc. And then for data structures, we talked about things like lists, tuples, sets, and dictionaries. All right, and there are a lot of other types of data structures in Python, but these are the basic. All right, there are other ones. So you could go to this link here when you get the notebook, W3 Schools, and you see a lot of all these operations. Now, you will also see stuff called built-in operations. Let me just add that link here. They're called built-in functions. So what do those built-in functions do? Very simple. They are functions that operate on anything, irrespective of the data type or data structure that it is. So let me put the link here so that you can just go visit it much later. Let's look at a bit of some of these built-in functions. So for example, ABS returns the absolute value of a number. So let's just go to this place and bring in a number. So let's say we have the first number, let's call it number A, or let's just call it A. And let's say A is -5, all right? So if we want to return the absolute value means you don't have any negatives or positives, just return a positive value, all right? So if we want to return that, what are we going to do? Very simple. We're just going to use the abs function. But here is the difference, and this is one of the things that's going to help you very well in your Python programming. If you look at this list of built-in functions, abs, or any, ASCII, all of that, you would notice that all the built-in functions have to come on, they can stand on their own and they operate on whatever it is that they want to operate on. For example, this ABSA, if you just do this, ABS and wrap that A variable around, as in use the ABS to wrap the A variable, then it will give you what you want. It's the same principle for every built-in function. They stand on their own. Unlike lists and all the other type functions, string functions and all that, that you have to use the object dots. You see, if what I'm saying is this, if this method, sorry, just go back. If this method were a list method, we would have needed to say A, which is the list dot ABS. All right. And then you see we have an error because it's not a method, it's not a list method. Let me use one example that would clarify everything. Now let me use a list. So people in class. Okay, so let me just put 3 names here. Oge, Bamidele. I'm sorry, that should be a capital B. Let me put the third person Dita. Okay, so these are the people in class. All right, and now if you look at this, this is a list, obviously, it's a Python list. Now, if I want to get the number of people in this list, there is a Python built-in function that does that. It's called len, L-E-N, all right, which is this. Come on, where are you? A-F-G-H-I-J-K-L, yeah, L-E-N. So if I do this, if I just bring it in here, and I say len people in class, it tells me 3, which means that there are 3 people in class. All right. That's how built-in functions work. You have to use them to wrap the item or the variable or whatever it is you're trying to check for inside of them, and then they give you the answer. But every other function, for example, let me go to list functions. List function. Sorry, I'm scrolling very fast. Okay, so let me use this list methods. All right, so for example, I want to say count. Okay, for example, I want to say count. All right. You can see that this one is the same way it's written. The name of the variable and then 2 brackets. You can see it's the same thing. Name of variable and 2 brackets. But let me go and use this count. All right, here. Then come. Let me see count. You'll see an error. So, but if I say people in class dot count, so it takes 1 argument. What is the argument? Let me just find that out. People in class dot counts value. Oh, okay, yeah. So okay. What is the right requirements now? Just allow me to remind myself that. Okay, so oh yeah, okay. So thank you. Yeah, it counts how many times something appears in the list. So yeah. So let me use Oge. Yeah, so it tells me Oge appears once. All right. But if, for example, I put Oge here, it now tells me Oge appears twice. So that's basically how you use this count function. And built-in functions, anything you see on this list of built-ins, you have to put them first, then wrap the variable on the inside. But any other thing like list methods, dictionary methods, and all that, you use the name of the list or the name of the dictionary, and then the dots, and then the method. that you're trying to use to get what it is you want to get from this place. So that's how it works. Now, these are various methods that are available in a list, all right? So there is the append method, there's the clear, there is the, let me just delete this list since I'm not going to use it. There is the copy, there's the count, extend, index, insert, pop, etc. So let's just look at a few of them and see how they work. So this is my lists, people in class. I'm just going to delete this one here and let's go. So the first is append. So let's just look at this. People in class, just copy this and sorry, dot append. Now, again, append takes one word. One of the things that you would notice about each of these methods, if what you're dealing with is a list method, they would take lists inside of the parentheses. That's they'll take what is inside of the lists. All right. So if the list has strings or whatever, that's what it will require inside of the parentheses, the content of the list. All right. So if we say append somebody to the list, so let's assume that somebody else joins the list. Let's use Soma. All right. Now, when we come here and now ask Python for the people in class, Python is now going to give us 4 names because we've asked Python to append, right, one more person to the class. So 1, 2, 3, 4. Initially, it was just 3, 1, 2, 3. We asked Python to append one person, then he appends this person. Okay, so the next method would be okay, so dot clear. You can use that to clear everything in the lists. So let me go back to this place and people in class dot clear. Now you'll notice that this one does not require anything. Come on, why does this just go back to the search every time? So when we run people in class now, see it's an empty list. All right. So that's what dot clear does. Now, okay. So people in class, you notice, is now that variable name is gone. All right. So now let me recreate that people in class. Can use this one. And then let me assign it back to okay. Data and daily. Okay, so how about people? Sorry, I'll have people in class. All right, so go back. Now, there is the copying of the lists, all right? And I think there is also dot view. So let's see if dot view works. It's been a while since I used it, but let me just try it out. So let's do a copy of these people in class now. Let's say my friends, which is, I just want to tell somebody, my friends are the same people who are people in class. All right, so people in class dot copy. All right, so when I now ask the computer, who are my friends? Guess who? Yep, same people in class. So what this method does is it helps you just copy the values, all right? But it doesn't retain the relationship in the sense that, for example, I can decide to say my friends, I can decide to say my friends dot append, and I can want to add summer, all right? So now I can ask Python, who are my friends? And it gives me 4 names. So you can see that it doesn't retain that connection between this and this. But if I had used my friends equal to this dot view, so let me come here and overwrite that variable. So equal to people in class dot view. Let me see if that works. Aha, okay, so dot view is not available for, it's not available for this. Okay, okay, I'm going to confirm that. I know it was available one time, I think. I'm not sure anymore now, but I'm going to just reconfirm that. Okay, so you can just try your hands on top of all of this. Insert, pop, remove, reverse, sort, etc. You can try your hands on them by way of homework, all right? So that you can just get a grip of how things work in Python. So you can also try your hands on all of these other methods. There, trust me, like I always say, do not be afraid to break things. When you try them, you would get some results. It might be correct, it might be wrong. If it's correct, you'll be happy. If it's wrong, you'll learn. All right. So that's how I learn. I try to I try to break things. I just try to just use whatever it is that I use, just see how it works. Then, okay. So, but much later, because when we start moving into object-oriented programming, we will need to touch some of this stuff in bits, in more details. We touched this like string and co last week. So we will touch some more things like next, like this, like iter, like what do you call it now? When we start talking about Python, iterators and generators and objects, generally object-oriented programming in Python. So that's how it's going to work. All right. I think with that I have covered a bulk of what we wanted to do today. Like I said, you can try all of this for yourself. It's not something very serious, or you can just try it. Remember, if it's a list method like this, it has to be the name of the list dot the method like this dot append. All right, the name of the list dot append. All right, name of the list dot clear, name of the list dot copy, dot count, dot extend. All right, anything. Okay. So you'll notice that there are some that require 1 argument or 2 arguments or any number of arguments. There are some that don't require arguments. For example, like this dot pop doesn't require any argument. So if I say people in class dot pop, what it does is it removes the last name there on that list. So when I now run this, my friends, again, you'll notice that there is just 1 name there. Okay, so that's how it works. It just pops the last name on the lists. All right, just pops it up. Okay. So remove reverse. Oh, this reverse is a bit, it could be a bit tacky. Let me explain what I mean by when I say it could be a bit tacky. So let me bring out the variable people in counts and people in class again. All right, so we can see now that there are just 1, 2 people in class. Okay, so if I say reverse, what I want to do is I want to reverse, I want data, which is this one, to come before okay. So normally if I say people in class dot reverse, and I just do this, you'll notice that it's not asking me for any parameters inside of the brackets. All right. So when I press enter and I now tell this give me people in class, you see what has happened? It has switched this, it has switched the values to, data, then okay. So that's what that does. And there are some times that you might need to, would I be going to advance into the class? Okay. I think we will stop there. What I wanted to say, and I'm going to take it in the next class. So if you have any questions, this would be a great time to ask. If you have any questions. Any questions at all? Okay. Nobody's asking any questions. I'm just going to assume that everything went well. Okay. So in the absence of any questions, that means we can adjourn the class and start getting ready for the next class. Okay, so thank you so much for the class. I understand if I'm saying built-in and list. Oh yeah. So yeah, built-in functions work on everything. It can be a list, it can be a dictionary, it can be anything. A built-in function can work on anything, even a number, anything at all. All right, but list functions work on lists. Dictionary functions or dictionary methods, you can see them, they work on dictionaries. Tuple methods work on tuples, set methods work on sets. And yeah, so it's usually very interesting, trust me. Very, very, very interested. Hey, Yola, welcome. Hola, you're late. Well, Happy New Year. Great to see you. Okay, so Ola is a Python and Power BI guru, and I think she's from Kuwait, right? Ola, you there? Yeah, okay. So, all right. Okay. Yay, hi, Ola. Okay, cool. So, if there is any question, we'll be glad to take it. But if there is none, then we will adjourn. But I know some of you are not very geekish, if I would use that word, but there is a class that we run. The class is going to start in the next 30 minutes. It's called Machine Learning Foundations. So that class is about math and statistics, basically, because those are the two things at the foundation of machine learning, math and statistics. And we are building the mathematical foundation right now with things like linear algebra and calculus and how to implement them in Python. The whole idea is so that tomorrow, if you want to go into machine learning research or artificial intelligence, nothing is going to phase you. You can just go in and do whatever you want to do. And then when researchers are talking, you are not going to get scared, because you have a very solid foundation. So that's what the class is all about. Now, it looks very geekish, trust me. But if machine learning research or AI is something you think you want to do much later, you will love the class. Because, yeah. Oh, hola. No, that session is going to start in the next 30 minutes. The session you're talking about is going to start in the next 30 minutes. So you're going to get a mail shortly. The time has not changed. Yeah. So this one is the Python Foundation class. That's the one we just did right now. All right. So everyone, you get a mail inviting you with the joining link for the Machine Learning Foundations class. But hey, no worries if it's not your thing. Or if AI is your thing, we'll be glad to have you around. Yep. All right. So thank you, everyone. This is where we shall stop the session for today. All right. Thank you guys for showing up, and we'll see in the 2 p.m. GMT class if you show up. All right. Thank you. Bye, everyone.